Hello, my name is Muhammad Arasnaki. So for this slide, I will explain our integrated prototype design for the smart bin that we've drawn. On the left hand side is our design, of course. So let me explain how this works one by one. So at the top, we have the silk solar panel which provides renewable power to the entire system. Just below it, we installed the HCSRO4 ultrasonic sensor which detects when a user is near the smart bin. Inside the unit, we place the Arduino control box. This is the central brain that processes inputs from all sensors and controls the dispensing mechanism. Next to it, we included an RFID or user ID scanner which is used for user identification before the smart bin is dispensed. On the front, we have the touchscreen interface where users can interact with the system and receive instructions. At the bottom, we have the dispenser mechanism which releases the feed, and finally the feed output chute where the feed exists safely for the users to collect. Overall, this cross-section demonstrates how all the hardware is organized and integrated into one working prototype. And for the second slide this slide gives a clearer view of each component's exact placement. You can see how the wiring connects from the ultrasonic sensor and the solar panel down to the control box. The RFID scanner and the touchscreen are positioned at the front for easy user access. The dispenser is located in the lower section of the structure to ensure smooth feed output, and the chute is angled to prevent blockage. Everything here was designed to support a simple, automated and user-friendly experience. In summary, our prototype focuses on sustainability, automation and efficient resources distribution through a clean and practical layout for the user to access easily and effectively, of course. So that is all from my part. Moving on to the next presentation.
Hi, my name is Muhammad Afiq. So now I'm going to explain the idea of our smart bin. At this point, the bin is already turned on and all the components you see in the slide like the ultrasonic sensors, the Arduino board and the solar panel are running the background, but since no waste has been thrown in yet, nothing major is happening. The ultrasonic sensor is basically just watching the space inside the bin because there is nothing in front of it. The distance readings stay the same, so the system doesn't active anything. For the Arduino is also looping as usual, checking for changes, but since everything is normal, it just keeps the bin in standby mode. The solar panel is still powering the system, but because no motors and mechanisms are working, the energy usage is super low during this time. And things like the RFID scanner and the touchscreens aren't being used yet either because there's no user interaction. So basically the ideal state is just smart bin waiting, everything is on, everything is ready, but it's just watching and waiting for someone to approach or throw in waste. So that's it from me. I will pass to the next person.
So hello. For the third slide, I will be presenting the simulation for the waste detected system. So since we've already established the system is ready and waiting in its idle state, what happens next is a user walks up and deposits their waste, for example an empty plastic bottle. This action instantly triggers our waste detection state, and our HCSRO4 ultrasonic sensor, which is positioned to watch the main bin entrance, immediately registered a change. The sensor is constantly shooting out ultrasonic signals and calculating the echo. When that piece of waste is placed near the bin, it suddenly blocks the sensor's path. So if you look at the right hand side, the first one is the termination simulation. So you can see that the system screams alert object detected. So our core logic here is simple. The distance reading suddenly drops. It goes from the wide open 150 centimeters we saw in the idle state all the way down to a closed 5 centimeters. This suddenly drop in distance and the crucial signal that tells the Arduino control box that a deposit has been made. The system then begins validating and changes the status signals to processing deposit. Now that the waste is detected, the system knows exactly what to do next and it's time to reward the user.
Okay, hi. For my part, I will be taking reward logic triggered. So this slide marks the successful completion of the waste deposit cycle and highlights the key incentive mechanism of our system, the reward logic. Immediately after the ultrasonic sensor confirms the object is deposit and validated, moving us from the processing deposit state, the system automatically triggers the reward sequence. As you can see in the slide, it said plus 100 points. It means that the user is instantly awarded plus 100 points after they redeem the reward itself. And then the rewards can be transferred to any type of rewards that will be given to the person. This process is managed entirely by the Arduino control box. The Arduino sends a secured timestamped signal directly to a centralized user database. This is a crucial step. The user's profile is updated instantly and in real time. So, this allows us to complete the feedback loop, ensuring two critical things happen simultaneously. First, which is the database is updated, reflecting the new point balance, and the second is user is notified, typically via a push notification to the companion app, which is they developed themselves about the reward itself, and then confirming the reward and providing instant positive reinforcement for the eco-conscious action. In conclusion, this point system is the primary driver for user adoption. By offering this tangible incentive, we are not just providing a trash bin, we are creating an active rewarding system that encourages consistent engagement in recycling. The point value is also flexible, allowing us to adjust it based on the type of material or future operational strategies. So that's all for my part, and then I will be passing up to the next person for the next part.
Now I'm going to explain how the power in our smart trash bin flows using the solar power concept. For the first one is the flow starts with the solar panels placed on top of the bin. Its main job is to capture sunlight and convert into electrical energy. This is what makes the entire system sustainable and suitable for outdoor use. After the solar panel generates electricity, that energy flows directly into the battery storage, and the batteries charge throughout the day, storing energy so the system can continue running even when there is no sunlight. This step is important because running even when there is no sunlight. This step is important because it ensures the bin always has power available. For the next one, the stored energy flows from the battery to the Arduino system. This includes powering the microcontroller, the sensors, and any additional components like indicators or dispensers. Basically, everything electronic in the bin depends on this energy flows. Because the battery stores enough energy, the whole system can operate 24/7 hours. That means it continues working at night during cloudy weather and even in the shaded areas. This entire power flows from the solar panel to storage to battery storage, and when the Arduino system makes the trash bin energy independent. We don't need to connect it to the main power grid, which reduces maintenance, lower operational costs, and allow us to place it almost anywhere. So that's it. This is my part. I will pass to next person.
Part of the app focused on the reduction features, which rewards users for the responsible waste disposal. So each time a user throws a trash into the smart solar trash bin, The system automatically records the action and converts it into points. Their points accumulated over time and can be viewed on the user's dashboard. In the redemption tab, users can choose how they want to use their points, whether it claim discounts or vouchers and eco-friendly products, and lastly community rewards. The interface is simply and user-friendly, shows available rewards, required points, and a redeem button for quick claiming. And this feature encourages long-term participation and motivates environmentally conservation behavior and builds a more suitable community. Instead of just disposing waste, users feel valued and rewarded for contributing to a cleaning environment. Thank you.